So hi all, welcome to the lecture series on solving the previous year questions of GATE ECE, and we are solving the questions related to analog circuits. So here this is the part 6 of this lecture series, and we will be starting the questions related to op amps. Okay, so this is the first question, today's question, that is from GATE 2025. So the question is, all the components all the components in the band pass filter given below are ideal. The lower minus 3 dB frequency of the filter is 1 megahertz. Okay, the upper minus 3 dB frequency in megahertz is dash. Okay, so given this is a band pass filter, so this is a band pass filter, and so since it's a band pass filter, okay, it will have a lower cutoff frequency and upper cutoff frequency or higher cutoff frequency. So I'll call it as FU. Okay, and given this lower cutoff frequency, FL is equal to 1 megahertz, and the question is to find the upper cutoff frequency. Okay, so if you analyze the circuit, which is the RC component which results in this FL, so that is this one. So this results in the lower cutoff frequency, and this results in the higher cutoff frequency. Okay, this RC network. Okay, so from the circuit itself we can write, okay, FL is due to, right, FL is equal to okay, it will be a function of R and C of lower cutoff frequency, or we can say like it's like a low pass filter, right, low pass filter component. Okay, so here that will be equal to 1 by 2 pi into RC, so R into 10C, so this will be lower cutoff frequency. Okay, so given this lower cutoff frequency is 1 megahertz. Okay, so from here I can find what is 1 by RC, right? So I can keep this RC here, and 2 pi and 10 I can bring that side, so it will be equal to 2 pi into 10 into 1 mega, or it will be like 20 pi into 10 power 6. So this is 1 by RC. So why I found this 1 by RC component is because in the higher cutoff frequency component again there is an R and C, and in the question R and C is not given. So if I have this value, I can substitute it in the next component and find the higher cutoff frequency. Okay, so now the higher cutoff frequency FH will be a function of R and C of the higher cutoff frequency component, or it's like high pass filter, right? This is similar to an high pass filter. Okay, so this will be equal to 1 by 2 pi into the resistance R is 2R into the capacitance is 0.1 C. Okay, so I can write this as 1 by 2 pi into 2 into 0.1, that into 1 by RC. Okay, so I will substitute this 1 by RC from the above equation. So I will get 1 by 2 pi into 2 into 0.1 into 20 pi into 10 power 6. Okay, so this 2 I can cancel, it will be 10, this pi I can cancel, right, 2 will go 5 times, and 5 by 0.1 is 50 megahertz. Okay, 50 megahertz. So the question is in asked to write in megahertz, that's why. Okay, so answer is 50. Answer is 50. Fine. Yeah, so that was the first question. Now coming to the second question, again this is from GATE 2025. So it's a digital to analog convert DAC question. So question is, a 4-bit weighted resistor DAC with inputs B3, B2, B1 and B0, MSB to LSB. So this is MSB and this is LSB. Oh, sorry, not this. This one is the LSB. It's designed using an ideal op amp as shown below. The switches are closed when the corresponding input bits are logic 1 and open otherwise. Okay, so when the input bit, okay, so the question is like when when the value of B3 is 1, then the switch will be closed like that. Okay, or B2 is 1, the switch is closed, and if B2 is 0, the switch will be open like that. Okay, yeah. So given when the input B3, B2, B1, B0 changes from 1110 to 1101, okay, the magnitude of the change in voltage, output voltage V0 is dash. Okay, so question is like initially the bits were equal to 1110 and it is changed to, so I will call this as okay, I will call it as capital B1. Okay, so this corresponds to the bit stream. Okay, B1 is input bit stream is 110, it is changed to B2 equal to 1101. Okay, so for B1 equal to 110, the output will be some V0 will be equal to V01, and it is, since input is changed to 1101, it will be now V0 will be equal to V02. Okay, the question is what is the change happened in this magnitude? Okay, that is what is the change, right? Change in magnitude. Okay, change in magnitude of output, that is I need to find mode V01 minus V02. Okay, so first what we will do, we will just apply the input B1 equal to 110. So when it is B1, so this switch 110, it will be connected like this. Okay, so how to find the output V0 here? So since this is grounded, this is also virtual ground, right? Okay, so this node is actually at 0 volt. Okay, and this node, all node is at 2 volt. Okay, so because of this there will be current flow, right? So I can call it as I3, I will call it as I2, and this I will call I1, and I will call I0. Okay, so for input 1110, the net current, so this current will be flowing like this, right? Entire current will be flowing like this through R, so I will call this IR. Okay, and this IR will be equal to, when it is 110, this current will flow, I3 will flow, I2 will flow, I1 will flow, while this switch is open. Okay, this switch is open, so there won't be current due to the I0. Okay, so IR will be equal to I3 plus I2 plus I1. Okay, so what is I3 here? I3 is the voltage across this resistance R by the resistance R. Okay, so what is the voltage across this resistance? Each resistance voltage across each resistance when switch is closed is 2 volt itself, because this is 2 and this end is 0. Okay, so it is like 2 by the current I3 is resistance is R, right? This resistance R. Okay, similarly I2 is the voltage across is 2 and I2 is the resistance is 2R, right? So it is by 2R plus I1 is 2 by 4R. So this is the current when B1 is 1110. Okay, which implies what is V0 now? V0 is like, since current IR is flowing like this, voltage will be dropped like this, plus minus. Okay, so V0 will be equal to IR, okay, minus IR, okay, minus IR into R. So here IR is 2 by R plus 2 by 2R plus 2 by 4R, that into R. Okay, so R can be cancelled here. Okay, so this will be equal to 2 plus 2 by 2 is 1 plus 2 by 4 is 1 by 2. Okay, so this is 3 plus 0.5 is 3.5 volt. Okay, now when for input 1101, that is B2. Okay, what will be IR now? IR will be due to I3, I2 and I1 will be 0 now because this is 0, right? So the next is I0. Okay, only I0 will be there. So if I substitute this, I3 will be the voltage across the resistance R by the resistance R. So it is 2 by R plus I2 will be 2 by 2R, and I0 will be 2 by the resistance is 8R, right? So 8R. So what will be the voltage V0 now? So this was V01 and this is V02. Okay, V02 will be 2 plus 1 plus 2 by 8, right? 1 by 4, that into the resistance. So all resistance is R. Okay. Okay, that is I minus IR into R, same. So this will be minus of this one. So R is cancelled and I will get 2 plus 3 plus 1 by 4 is 3.25 volt. Okay, so the question is to find V01 minus V02, right? Magnitude of V01 minus V02. So V01 is 3.5 minus V02 is 3.25. So I will get 0.25. So this is actually minus. Okay. So anyway, we are taking the magnitude, so it doesn't matter. So 0.25 volt or 250 millivolt. Okay, because the question is given in asked in millivolt, so it is 250 millivolt. So that was the second question related to digital to analog converter. Okay. Now coming to the third question, that is from GATE 2024, is the op amps in the circuit shown are ideal but have saturation voltage plus or minus 10 volt. So these op amps are having VSAT to be plus or minus 10 volt. Okay. Assume that the initial inductor current is 0. So here the 0 ampere current through this inductor. The input voltage Vi is a triangular signal with peak voltage plus or minus 2 volt and the time period of 8 microsecond. Which of one of the following statement is true? So the question is, Vi is a triangular voltage like this, and the peak is, this is at 2 volt and this is at minus 2 volt, given the current through inductor is 0. Okay, and the statement is like a V01 is delayed by 2 micro second relative to Vi, and V02 is the triangular waveform. Okay, B option is V01, okay, is delayed relative to Vi, V02 is trapezoidal waveform, V01 is not delayed relative to Vi, V02 is triangular waveform, V01 is delayed by 1 microsecond relative to Vi, and V02 is a trapezoidal waveform. So question is like we need to find what is the value of V01. V01 is the voltage output voltage of op amp 1, and V02 is the voltage output voltage of op amp 2. Okay, so what we will do is like we will find first V01. Okay, we will find what is the voltage V01. Okay, so I will just draw the first. Okay, I will draw the first part here. So this OA1, this is ground, okay, so this is V01 and this is 100K and this is 10K, and I have the V input. Okay, so we know the voltage, so this is a positive feedback, right? It's a positive feedback circuit. Why? Because the voltage, output voltage is fed to the V plus terminal, right? Plus terminal of the OA1, non-inverting terminal of OA1. Okay, so since it's a feedback circuit, the voltage V01 will be plus 10 volt for V minus less than V plus. So what is V minus? V minus the voltage at this node, or V minus is actually 0 volt, right? It is actually 0 volt. So this will be plus 10 volt when V plus is greater than 0 I can write. So whenever this V plus voltage is greater than 0 volt, it will be 10 volt, and V01 will be equal to minus 10 volt, that is V01 will go to minus 10 volt when V minus is greater than V plus, or I can write minus 10 volt when V plus is less than 0, right? So what we will do is like we will find what is this V plus. Okay, so from this circuit, what is V plus, I can apply the superposition theorem, right? Because here one voltage Vi is there, here one voltage V01 is there. So voltage due to Vi at this V plus is Vi into this resistance, right, 100k, because when Vi is taken, I should assume that this is grounded. Okay, and when V01 is taken, we will assume this as grounded. Okay, so it will be a potential divider. So Vi into this 100k, okay, this 100k by the net resistance 10 plus 100k. So that is the voltage due to Vi plus the voltage due to V01. So what we will assume? We'll assume like Vi is grounded. So near to 10k it is grounded, right? So V0 into 10k by 10 plus 100k. So yeah. Okay, so I can write this as Vi into, so if I solve this, it will be 100k by 110, right? So I can write as 10 by 11 plus V0 into 10 by 110k, right? So it will be 1 by 11, right? So this is V plus. Now if you observe here, as we told, V01 will be equal to plus 10 when V plus is greater than 0, right? So I will set this. So say Vi into 10 by 11 plus V0 is now plus 10, right? So 10 by 11 greater than 0, or Vi, so this is cancelled, right? So Vi greater than minus 1. So whenever, which means when Vi is greater than minus 1, V0 will be equal to plus 10 volt. Okay, when Vi is greater than 1, whenever the Vi is increased above minus 1, V0 will be plus 10 volt. Okay, and V01 will be equal to minus 10 volt when V plus is less than 0, right? So if I substitute it, Vi into 10 by 11 plus instead of 10, V0 will be minus 10, right? So minus 10 by 11 greater than 0. So 10 by 11, 10 by 11 cancelled. So when Vi is greater than, sorry, not greater, less, right? Okay, when Vi is less than 1. So when Vi goes below 1, okay, the output V0 will be going to minus 10. That's what. Okay, so Vi will be, Vi is less than 1 volt, V0 will be equal to minus 10. So it's actually a Schmidt trigger, right? So how the voltage will be? So I can draw here. So if this is the signal, this 2 volt, this minus 2, okay, so this is the Vi, okay, so this is 0, this is minus 1, this is 1, okay, yeah. So V out 1, okay, V01 will be like, so whenever Vi is greater than minus 1, so this is minus 1, okay, when Vi is greater than minus 1, the output will be plus 10. So from this point the output will be plus 10 volt. Okay, so till that it is minus 10. Okay, and whenever and the voltage Vi is increasing, and whenever the voltage go below 1 volt here, okay, after this when it goes below 1 volt it will go down, right, it will go to minus 10 volt. Okay, and again it will go up when the voltage is going above minus 1. So I will get a square wave like this. Okay, so this is what I will get at V01. And now if we see, the question is like whether V01 is delayed with respect to Vi. Okay, so Vi is at this point, and given Vi is 8 microsecond, right? So the period of Vi is 8 microsecond, which means this rising and falling will be of 4 microsecond, and we can divide this as, since it's 4 microsecond, from we can divide into 4 sections, 1 2 3 and 4. Okay, so this corresponds to, so from minus 2 to 1, this corresponds to 1 microsecond, minus 1 to 0 it require 1 microsecond, and so on. Okay, so which means when even though the signal starts at minus 2, the transition starts at minus 1, which means it is actually delayed by 1 microsecond. Or so from 0 it is delayed by 1 microsecond, that also we can see. Okay, so this is not aligning with the 0, so there is a delay, right? So V01 is delayed by 1 microsecond, okay, with respect to Vi. Okay, so that is the answer. So actually if you see here, this we can see in option D, V01 is delayed by 1 microsecond related to Vi. So mostly D will be the answer. We will also see what happens to V02. Okay, so coming to V02, okay, so this signal V01 is given to an inductor, and through inductor it is given to an inverting amplifier like this. Okay, and this resistance is 1K, and this is inductance is 1 milli, and this is V02. Okay, so what happens here, so this V01 is a voltage applied at this end of the inductor. So if there is a current, this IL will be flowing like this, right? So there will be a voltage drop like this, plus minus. So V02 I can write as minus IL into 1K. Okay, so what is this IL? So there is a voltage V01 across this inductor, and this is virtual ground, right? So this is like a ground. So current through the inductor of inductance 1 milli will be equal to 1 by L integral of V01 dt, that is the current, okay, that into 1K. Fine, so this will be the V02. Okay, so this will be the V02. Okay, so we will see, suppose what is V01 here? V01 is this one, right? So say this is V01. Okay, so what will be actually V02? V02 is actually integrating this V01, right? So according to this equation, so it should be something like this. Okay, it should be something like a triangle wave. So we will see how much voltage it will integrate during this period. Okay, so if you see from this figure, this point is 1 millisecond. So I will call this as this at 1 milli. Okay, it's not 1 milli, it's 1 micro, sorry. It is in 1 micro. Okay, and this point, what is this point? This is plus 4, right? So that is 5 micro. So this is like, this is at 5 microsecond. Okay, so we will integrate from 1 micro to 5 micro. So what happens here? It will be, I will integrate, so 1 by L is 1 milli integral 1 micro to, so I am finding V02 in the range 1 micro to 5 micro. Okay, so 1 micro to 5 micro, V naught 1 during this time is how much? It is 10 volt, right? It's in saturation plus 10, so 10 volt dt into 1k. Okay, so I'll write like 1k by 1 milli into 10, and I integrate this, right, t from 1 micro to 5 micro. So what is this? 1k by 1 milli, it is like 10 power 6 into 10, and 5 micro, right, it will be 5 minus 1 micro, so it is like 4 into 10 power minus 6. Micro is 10 power minus 6, so this cancel, 10 power 6 and 10 power minus 6 cancel, this will be 40 volt. So actually this will go till 40. Okay, but the given question, op amp O2 is having a saturation voltage of plus 10, so it should not go to 10 40, instead it will integrate and saturate at 10 volt. Similarly, and in negative also it will saturate at minus 10 volt, so it will be something like this. So this is what, this is actually a trapezoid. So the answer is V02 is a trapezoid waveform. Okay, so answer is D. So V01 is delayed by 1 microsecond and V02 is a trapezoid waveform. Okay, now we will go to the fourth question. In the circuit below, the op amp is ideal if the circuit is to show sinusoidal oscillations. The respective values of R1 and the corresponding frequency of oscillations are. Okay, so question is like it's an oscillator. So as you can see, there is an amplifier, inverting amplifier, and there is an RC circuit. So from the circuit, so we say this is V0, and this voltage is V plus, that is voltage from here. Okay, it's like a feedback. Okay, so I need to find the frequency of oscillation and the corresponding respective value of R1. So how to find? We'll find the value of oscillation first. So to that we need to solve the or find the omega value from this RC network. Okay. So let this voltage will be V1 at this node V1. So I'll apply, okay, I'll apply KCL at 1. Okay, 1 is this one. Okay, so what will be the KCL? So it will be V1 minus V0 by 1 by SC. So where C is the capacitance, which means its impedance is 1 by SC here also. Okay, minus the current through the bottom resistance, that is V1 by R, and this node is V plus, right? Okay, plus V1 minus V plus by R equal to 0. So if I club the values of V1, I will get 1 by 1 by C is SC plus V1 by R plus V1 by R is like 2 by R, right? So I will get 2 by R. Okay, minus V0 by 1 by C, so SC into V0 minus V plus equal to 0. Okay, so this is equation 1. Okay, similarly I will apply, so let this be the node 2. Okay, so I will apply KCL at node 2. Okay, so what I will get, current here is 0, right? It's a non-inverting terminal, so there is only current in this node and capacitor. So how it will be? V plus minus V1 by R plus V plus by 1 by SC is equal to 0. So if I club V plus terms, it will be 1 by R plus SC equal to 0. No, it's not 0. There is V minus, sorry, V1 term also, right? So minus V1 by R equal to 0. Or from here, what is V1? V1 is R into V plus into 1 plus, I can write S into RC by R, right? So R cancelled. I can write V1 as V plus into 1 plus SCR. Okay, so this is equation 2. So I'll apply or substitute equation 2 in 1. Okay, so above in equation 1, V1 I'll replace with V plus into 1 plus SCR into, there is one more term, SC plus 2R, right? So I'll take R as denominator, so it will be SCR plus 2 by R, right? That minus SC into V naught plus, not plus, plus minus, right? Sorry, minus V plus equal to 0, right? So I missed this R here. Yeah. So I will again club the V plus terms. So if I expand these two terms, it will be SCR 1 into SCR plus 1 into 2 plus S square C square R square plus 2 SCR. So this will be the term, and remaining is 1 by R minus SC into V naught. Okay, so I'll just reduce this. So I have 2 SCR terms, so it is 3 SCR. Okay, and plus S square C square R square plus 2. Okay, and there is 2 and 1 here, right? So 2 minus 1 is 1, so I can reduce that too. So I can combine that too. 2 minus 1 is 1, so 1 by R is equal to SC into V naught. So what is V naught by V plus then? V naught by V plus will be 3 SCR plus S square C square R square plus 1 by the SC come below means SC into R. Okay, so I can write this as 3 plus S square C square R square plus 1 by SCR, right? Or I will substitute SC equal to J omega. So what happens? 3 plus this will be J omega square is minus omega square, right? So minus omega square R square into C square plus 1 by J omega RC, right? So this is V naught by V plus. Okay, but if we see this circuit, it's a non-inverting amplifier, right? And input is V plus. So what will be V naught? V naught will be equal to V input V plus into 1 plus R1 by R, right? So I can write this from non-inverting configuration, right? I can write V naught by V plus as 1 plus R1 by R. Okay, so if I substitute this, 1 plus R1 by R will be equal to 3 plus minus omega square R square C square plus 1 by J omega RC, right? I substituted here. So I have LHS and this is the RHS. Okay, so I will compare imaginary terms of LHS and RHS. So which is the imaginary term here? Imaginary term here is this term because J is there, right? And here it is 0. So I can write as minus omega square R square C square plus 1 by omega RC. So this is the imaginary term. This will be equal to 0 in the LHS, right? So from here I can bring this to 0, right? So it will be minus omega square R square C square plus 1 equal to 0, or omega square equal to 1 by r square c square. Okay, or omega equal to 1 by rc, or f equal to 1 by 2 pi rc. So this is the frequency. Okay, this is the frequency that we wanted. Okay, similarly, so I have, so I'll say this as equation 3. Okay, now I will compare real part of 3. Okay, in this real part, so no, not this one, sorry, I want to compare, we'll say this is the 3. Okay, so real part on LHS is 1 plus r1 by r, right? So 1 plus r1 by r is on the LHS, and here the real part is 3. So this is equal to 3. So I can write like r plus r1 equal to 3r, right? If I take the LCM, so r1 will be equal to 2r. So the resistance r1 should be 2r. So this is the answer. R1 should be 2r and the frequency should be 1 by 2 pi rc. So r should be 2r, right? 2r, and frequency should be 1 by 2 pi rc. So answer is B. Okay, so that's all. Thank you.